Hi everyone, welcome back to the Introduction to FPV Drone course on HackadayU. My name is Ayan and I'm going to be your course instructor. This is the class 2 and I already hope that you have attended the class 1 where we talk about the physics of drones, physics of flying and different components that goes inside building a drone, and specifically we discuss about the star of the class, that was the propellers. And in today's class we're going to talk about the drone frames, transmitters and receiver, which are the very vital components. So if you haven't already watched the class 1, I would highly recommend you go and watch that first and then come back to this class. So because this class has some prerequisite from class 2 class 1. But anyways, without further ado, let's start with today's agenda. So today we're going to be talking about the frame selection and how different things comes into the picture when you are deciding a frame for your drone application. We'll also be talking about if there are different materials available in the market. There are different options if you should DIY the frame, if you should buy someone else designed frame already off the shelf, or what are the number of propulsion system which are available in a frame, and what materials are they made up of, the shape of the frame, the geometry, and how to assemble it. So that about the frame selection. Then we will be talking about the transmitters and the receivers. We'll talk about frequency, the communication link, and how the communication happens when you send some data from your transmitter, and how the receiver receives it and it translates to the drone motion of your desire. We'll talk about frequency. We'll demystify some of the myths behind frequency, power, transmission losses and latency, and so on. There would be some maths involved in it, so that would be there. Then we'll talk about receiver compatibility. We'll talk about LRS and UHF, and we'll talk what they are. So for now, let's deal with the short forms here. Then we will also talk about telemetry and how data is sent back to the ground station to where the drone is being controlled. We'll talk about antennas, and that is a very interesting topic. We'll see how. We'll talk about what is Failsafe, and that's the agenda of class 2. That is today's class. So let's talk about the drone frame variety. And when in the last class I mentioned that when I'm talking about drone, I want you to think about a quadcopter, because drones can be of various type, as we discussed in the last class. It could be fixed wing, it could be helis, it could be even the military drone. But to be on the same page, to be on the same understanding level, I want you to think of a quadcopter, that is a drone with the four rotors on the top. We'll talk about drone frames, and we'll see how different drone frames are available for you to choose from. So on the screen you can see a very small tiny drone frame, which is also known as tiny whoop. This is a great beginner drone. It is meant to be fly indoors. It is using coreless DC motor, which are really cheap, and this also support FPV. As you can see, there is an FPV camera and transmitter. So there are a variety of drone frame available, and I'll show you in the overhead cam of different frames I have with me. But what are the frame option available? Let's see. So this is one of the quadcopter frame which you might have seen the most, because it's like a standard size frame, standard shape. That is the X shape, a very common geometry. When we talk about the quadcopters, we have 4 motors, we have landing gears. This frame seems to be made up of wood. We'll also discuss what are the advantages of having a frame made up of wood, as in this photo, versus the one which is made up of plastic, as the tiny whoop here. You also might have seen these kinds of frame, and these kinds of frame are especially very common in cinema industry, where they meant to carry some big cameras like DSLR, or even some cinema class cameras like Alexa Mini, Alexa the standard one, or the Alexa RE, even the red cameras and Blackmagic Design Studios. If you know some cameras from the film industry, you might have seen these kinds of drone. The landing gear which you are seeing are quite elongated. They are actually being folded. These landing gears fold up when the drones take off, and this landing gear comes back to this position when it's landing. This is also used so it can be picked up by someone on the ground. It can be hand launched if needed at certain areas. So that is why this elongated landing gears proves importance, and they keep the operator very safe compared to the one on the right side, because you can see there is quite a long gap in the landing gear and where the motors of the drones are. So it's comparatively safe, and we'll see about different frames. So This is a small DJI Tello drone which you can buy off the market, and you can see there's a small camera. Maybe you can see there are coreless motors. So comparatively, these two drones are almost same. They have almost same kind of motors. The the coreless DC motor. They both have cameras. I think this can do HD transmission, I believe, and this is a normal one. But these both are quite same. But you can see that the design, everything is enclosed because it's a commercial proprietary product. The company don't want to reveal all their electronics which are inside, and this is comparatively easy to get inside. So I'm just showing you the different drone frames so you get the idea of different quadcopter frames available in the market. Here is another one which is used by the FPV pilots like me for freestyle and drone racing. We'll talk about how these frames are different in construction, different in geometry, and what all flight characteristics it changes as the frame changes. And there's also this funny one. I think it's funny. I'm not sure about you, but this looks funny. It's like a very minimal drone, and this is meant for FPV racing, by the way. The arms are very small. The weight is very less because it has very less parts and all, but it has a very high speed. It can probably go up to 150 miles per hour or something like that because it's very small and very lightweight. But yes, these are all the drone frames, the quadcopter frames commonly available in the market. As you can see, everyone has different application. So that is the motive of showing you this slide, that there is not one frame which is the best for you. There is not one frame which I can recommend you to use. There are thousands of different frames in terms of geometry, in terms of material, in terms of how they mount the electronics. Like for example, here you can see all the electronics are exposed. Here it's inside. Then why someone choose to expose their electronics versus someone choose to hide the electronics. So things like that we're going to be discussing in today's chapter. So let me switch to the overhead camera and show you different type of drone frames that I have. So this is my go-to FPV drone freestyle frame, as you can see. So this is a frame by a company called Armaten Chameleon. So this is a frame from them, and I have modified it to suit my needs, and we'll talk about modifications in future chapters. So this is my go-to frame. As you can see, I have some other frames with me as well as like this. So this is a tiny whoop, as I showed in the PPT here. So this is the same frame, but it's disassembled right now. There are also a smaller one. So this is almost like a FPV racing, but this is a smaller one meant for very tight gaps, and mostly of the fun flying. It cannot carry a GoPro or HD cameras, but it has its own application. It has its own needs. So yes, we'll be talking about frames more in today's chapter. So let's continue. Okay, so the very first thing that you need to keep in mind when buying a frame is the frame size. So what size you're looking for. And if you remember in the last chapter, we talked about the propellers and how frames and propellers form a very big constraint that you need to clear on the very early on when you're deciding on what application you need to use your drone. So in the last chapter, in the last class, I showed that you cannot use any size of propeller on any drone frame because the frame has some constraint, the frame construction in such a way that it may not be able to spin one bigger propeller because of space constraint, because of some other constraints. So that is why if you have chosen the propellers already, you need to choose the drone frame. And when you're choosing a drone frame, the first thing you need to keep in mind is the size. So how do you calculate the size of a drone frame? So the size of a drone frame is calculated diagonally, motor to motor. So you take any diagonal, you calculate the distance between these two motors, the center of these motors, and this distance is in millimeters. So if you take a scale, if you measure the diagonal motors, in millimeter you'll get the size of the frame. So talking about my frame, so this is diagonally 130 millimeter frame. So from one motor to another motor diagonal, it's 130 millimeter. If you talk about this one, this is more like a 220 millimeter size frame. From motor to motor is 220 millimeters. So this is how the frame is calculated, the size of the frame is calculated, and that's how the frame are being designed. So it's called the drone frame classes. So a very common class is 450 size frame. And when I say 450 size frame or a 450 size class frame, what I really mean is that the distance from center of motor to other diagonal motor is 450 millimeters. and that is a very common frame, that is a very common size, more common before the introduction of FPV drones in the industry, because that is the only frame which was easily available. So if this is like a 450 size drone you are seeing, this is also somewhat like 500 class frame. So yes, that's how the drone frames are being sizes being decided. So if you talk about the FPV drone racing and freestyle, the class which we use, it's called 250 size frame, which can rotate a propeller of 5 or 6 inches. And when we say 250 class, it has anywhere between 210 millimeter to 270 or 280 millimeter of frame sizes. So the frame which I'm using here, it is a 220 millimeter diagonally motor to motor, so it comes under a 250 class, and 250 class frames are meant to rotate propellers from, let's say, 4 inches, 5 inches and 6 inches and so on. So that's how you decide the frame. If you have already know that you want to have a drone which is running a propeller of, let's say, 5 inches, then 250 class is a good class to go. If you want a drone which can rotate, let's say, 8 inches of propeller, then you might need to go for a bigger size of frame like 450 class and so on. Okay, so moving ahead, the second factor that is a deciding factor when you are going for a drone frame is number of propulsion system. And this is a very interesting thing to know, that why I would want my drone to have 3 motors or 4 motors or 6 motors, and what are different characteristics of each motor. So right now I want you to forget that thing where I talk about that drone is a quadcopter, and just let's come back to that after this particular slide, or this particular set of slides. So what is the propulsion system? So a motor and a propeller together form a propulsion system, which is actually producing thrust for a drone. So if you talk about a tricopter, it has a 3 propulsion system, that is, it has 3 motors. So you can see a tricopter by the name, it has 3 motors, and each motors on one arm. So these motors can speed up and speed down to give its roll and pitch axis. But what about the yaw axis? So we have seen in the last class that to have a yaw motion, you need to vary the speed of a diagonal motor. But this is having an odd number of motors. So how the tricopter is able to yaw on the degree of freedom of yaw axis? So the answer lies in its tail. So the design of the tail is such that this motor is mounted on a servo motor, and that servo motor rotates to give its thrust in a particular direction. And we discussed about thrust vectoring in the last class. So that is exactly how a tricopter do its yaw motion. So let me find a quick video for you, and where you can see that how tricopter does the yaw motion, and it's very interesting to see if you have not seen tricopter before. So let's see. So I am not having the top-notch workstation, so there might be some frame drops. I believe in the last video I've seen some frame drops. So I'll try to mention these videos in the Hackaday project page, so you can refer it later. So let's see if we can find. So tricopter tail servo yaw motion. I just need to show you a couple of seconds so you'll get the idea of how a tricopter do yaw. So I'm getting some frame drops already, so apologies for that, but this is the best we can do. So let's see if we can find that video. Okay, so I think this is the one. So you can see that the tail of the tricopter motor is mounted on a yaw mechanism, on a servo mechanism, where a servo motor controls the direction. I'll mute this one. So this is how the assembly is being done, and apologies for the frame drops. So this is showing this entire assembly, and we are more interested in the working. So let's skip here. I think this should wait. So yes, that's the servo motor, and that is how the brushless DC motor, the BLDC motors I use on drones, are being mounted. So now you can see that the servo has a property that it can rotate from 0 to 180 degree, and using that it will do some thrust vectoring. So how tricopter servo works? So this video will clear the doubt how the tricopter, even though having odd number of motors, is still able to yaw. So this is a tricopter frame, and yes, there you can see. Okay, there you can see that how the motor is continuously being changing the direction with the help of servo motor to keep it stable, even though having an odd number of motors. So that is exactly how a tricopter do a yaw degree of freedom in 3D space. So engineering is fantastic, and tricopters are really good. So the question arises, then why do someone would wants to build a tricopter? So I want you to see here. So see this angle between these two motors at the back. So this angle is so much that there is no obstruction. You can mount anything here. You can mount a spray, you can mount a camera, and there will be no obstruction from these propellers, because this is a very, very wide angle. If you look here, it's more than 100 degrees. So this motor goes here, this motor goes here, and still you have a lot of angle, you have a lot of clearance here. Because of this clearance, you can mount a camera here. No propellers will come into the picture. You can mount a jet spray here. And even in the last class, I show you one video of a drone ambulance made by some university in Netherlands. They're also using a version of tricopter. It's basically Y6, which will also come to, but they are using a version of tricopter because of very same reason. Because this space they are using to mount a screen and a camera to talk to someone who is assisting the patient. So that is why tricopter are very much used in these kinds of application where you need this big clearance, and you will not find this clearance in quadcopter, as we'll see in the next slide. Another reason one would want to build a tricopter is cost, because motors are expensive, propellers and ESCs are expensive. So when you are having more number of motors, you might also want to have more chances of failure. So that is why, to reduce the cost, you can build a tricopter. Another reason that is, I know a lot of people have built tricopter in the past, is the yaw authority, as they used to call it, because the yaw mechanism is not dependent on the speeding up and speeding down of the motors, and it depends on a mechanical assembly, a servo assembly, which is a good servo motor, a metal gear servo motor. So it gives a tricopter a very good yaw control, a very good yaw authority, and you can do very quick yaw maneuvers. And those who have already fly drone, they know that yaw is one of the axis which is really important in terms of flying, in terms of handling. So that is why there could be another reason to build a tricopter. So yes, that is a reason if you want to build a tricopter. And yes, we spend a lot of time talking about tricopters. So let's move to the next slide and we'll talk about quadcopter. So the very first thing I want you to notice is the angle which I'm talking about. So see how this angle reduces compared to the tricopter. It has this very obtuse angle, and in case of quadcopter, this angle is reduces. So the first disadvantage of quadcopter is very less clearance between two arms or two propellers. So if you are about to mount a camera here, high chances these propellers will come into the picture, and if you have not mounted it below or up, there are high chances if you have mounted on the center line that propellers will come into the picture. And again, if you want to mount something else like display or camera to talk to someone like the drone ambulance, then that may hinders that decision. Okay, but talking about quadcopters, one thing which you can notice is these two motors are marked blue because these two motors spin clockwise and these two motors spin anti-clockwise, which we already discussed in the last class. So because of that, it provides a very good stability, very stable performance in the air. So quadcopter are really stable drones. They are not aerodynamically stable because they don't have some airfoil or something which are reducing drag, which we have already discussed. But because of these two anti-clockwise and two clockwise spinning motors, they cancel each other out and they can be very much stable. And if you have programmed it right, if you have tuned it right, then quadcopter is one of the most stable drone frame which you can build. So yes, another thing which you want to build quadcopter compared to tricopter is one motor will give you more, one extra motor will give you more power, and we talked about thrust is to weight ratio and it's important. So obviously you will get more stability than the tricopter. Next, let's talk about hexacopter, and as the name suggests, it has 6 motors. So the question is, we already have tricopter, we already have quadcopter, most of the problems can be solved with it, then why someone would need to build a hexacopter? One of the major reason people in film industry are building hexacopter is, so yes, before that I'll let me tell you that hexacopters are mainly being used in film industry where people wants to mount big cameras, where people want to mount expensive cinema class cameras. There you'll find hexacopter. The very first reason they want to build a hexacopter is more power. So obviously you'll have 2 extra motors that will give you 2x more thrust compared to the quadcopter. Number three is redundancy, and hear me out and try to understand this concept. So you can see there are three motors which are rotating clockwise and three motors which are rotating anti-clockwise, compared to quadcopter where there are only two sets of one set of each. So if one of the motor or if two of the motor fails in a hexacopter, you still have a quadcopter setup and it is still very stable. So what I mean by that is, if you, let's say, is mounting a $50,000 camera, which is the cost of a cinema camera. You want some kind of redundancy, you want some kind of failsafe, you want some kind of feature that protects it if one motor fails or two motor fails, and that is exactly what hexacopter provides. It provides redundancy. If one of your motor or two of your motor fails, you will still be able to land it without any problem. You will still be able to control it in the air. So that is one of the major reason people who want to mount expensive gears on their drones, they prefer hexacopter over quadcopter. Octocopter, similarly, more redundancy, more power. So yes, if you're still not able to have your payload lifted with hexacopter, then you can add two more motors to get octocopter, and you'll get another layer of redundancy. So let's talk about some weird shapes, and it's Y6, the same we saw in the last class in the drone ambulance. So what exactly is happening here? So you don't want to change your frame. You don't want to keep adding motors, because at one time you will exhaust the available space and you will not have enough clearance between the propellers. So if we talk about hexacopter, see, there is very less clearance between the propellers, and you are basically exhausted the space available to you, and your propellers cannot spin. So what you'll do? So engineers have come up with great ideas that instead of keep mounting motors on one axis, let's mount motor on the below axis. So you have three motors on the up and three motors on the below. So that is how a Y6 work. It is basically two tricopter attached back to back, one on the top and one on the bottom. When you have a Y6, you'll see in the tricopter all motors are spinning in the same direction, but in the Y6 there are two sets of different motors spinning on different direction, which cancel out each other's thrust, and you don't need a servo mechanism as a tricopter did. So in the similar way, if you can mount a motor downwards, why not mount four motors downwards and get an X8? That is basically two quadcopters. And similarly, you can mix and match a number of propulsion system, and you can get these kinds of frame configuration. So far we talk about the drone size and the different shapes in which you can make the drone. Okay, now let's move ahead and talk about different materials that you can use to build drone frames. So basically, no one is stopping you to use any kind of material to build the drone you want. But there are certain materials that are being used already by different drone frame manufacturers, by different people around the world, and there are certain factors that are kept into consideration while building or buying a drone frame, and I have listed there in a table. It's cost, durability, weight, and signal interference. So as I already mentioned in the last class, that when you are talking about drones, everything is a trade-off. You will gain something, but you will lose a couple of things, and vice versa. That is why you need to find a sweet spot. You need to know on what particular ground you want to compromise on, and on what particular ground you don't want to compromise on. And I'll give you a very sweet example what I meant by that. So let's suppose I am a drone racing pilot, and I am flying drone at a very high speed. So what can I give up there, and what I cannot give up there? So definitely I cannot give up on the weight. I want my weight to be as low as possible. That is the only way I will be able to attain higher speeds. I can give on the cost, because I know that if I'm participating in a drone races, people will come there as my competitor with all kind of drone frames, with all best kind of material, and we are basically competing for a prize money. So cost is not a factor there. I cannot give up on durability, because when you are racing, you want your frame to be durable. Even if there are lighter crashes, you are able to make repairs, and you are ready for the next heat, and so on. So this is an example I want to give and talk about finding the sweet spot. So let's compare different materials. So on the left, you can see that these are the common materials which are being used for making drones. It's wood, plastic composite, G10 or fiberglass or carbon fiber. So Let's talk about wood. So, wood basically cost very less. So, there are different woods material which are being used in making drones. I am not sure, but I think pine wood is one of them. I have built a single or a couple of wood frames in the past, mainly for tricopter, and there I only want it to carry a GoPro and don't do any fast maneuvers like I do with my FPV freestyle drone. So that is why I'm not concerned about the durability. So wood can break easily, but because it is so cheap, you can replace it with a new part. So you can carry extra parts with you. You can make replaces on the go. So that is why the cost of the wood is very low, and also the durability is also very low. You crash, you'll break an arm or something. Uh, I also want to mention here that when I talk about durability, it's not only the frame durability, but also the protection frame provide to your electronics. So basically, what is a drone frame? It is nothing. It is a house of all your drone electronic components, and if the frame is not durable, it will break very easily. There are high chances that it will also break your components. For example, if your drone arms break, on the arms you have mounted your ESC, there may be ESC wire breakage, and because the battery is connected, there may be short circuit, and your entire electronics fry, and the magic white smoke comes out, and the possibilities are endless. So do also keep that in mind, that durability is not just the frame durability, but also the housing, the shell it provides to other components. Talking about the weight, that is a big factor for not choosing wood as an FPV racing or FPV freestyle drone, because the wood is very heavy, and the heaviness of wood is not suitable for such kind of application. But on one good end, there is no signal interference with the wood. Wood is not conductive, so there is no signal interference, and I will talk about signal interference when we'll talk about the other materials. Now let's talk about plastic composite. So some drone manufacturers, what they did, they are using some plastic polymers which are very durable, which are also very lightweight. I think ABS is one of them. There is a TPU which is also flexible, so it will never break. It's like flexible materials, you can never break them. So talking about plastic composite, the cost is, it depends on different frame manufacturers and different polymers which are being used in cost. So cannot really comment. So if it's a high quality plastic composite, it would cost more. If it's a low grade plastic polymer, it will cost less. There are some plastic which are mixed with resin and something. I don't know. I'm not the best guy to comment on that. But yes, I'm not really sure. The cost of the plastic, it would totally depend on the material. Durability wise, they are good. So I have seen some plastic frames floating in the market, and even in drone racing we are using plastics to enforce the frame. And the plastic I'm talking about is TPU. It's a flexible plastic, so it doesn't break. And yes, they are being used and they are quite durable, so that is a good thing with the plastic composite. On the weight side, I cannot really comment. It depends on the density. So these frames are generally injection molded. You may also find some 3D printable frames, but I'm not talking about them particularly here. I'm talking about injection molded frame. So how much dense they are, the density of the material, that will totally dictate the weight of this frame. So I have left that particular section. On the signal interference, again, plastics are not conductive, so there is no signal interference. So that is a good thing. I have marked that a red cross, but that is actually a good thing. There is no signal interference. That's what I mean by the red cross. Okay, so moving ahead, there is another material which is being used in making drone frame. It's quite popular a couple of years back because it's relatively cheaper than carbon fiber, and it's G10. So compared to wood and plastic composite, it definitely expensive than that, but it is far less expensive than carbon fiber. Durability wise, it totally depends on the manufacturing process. So what a G10 is, it basically a sheet of fiberglass, and they are sandwiched together, and they are pasted using epoxy, and the density of epoxy, the quality of resins used to make that epoxy, and so on, that dictates the durability. So I've left that one. The weight is very high. It's quite heavy compared to the carbon fiber, so that is a downside of it. Signal interference, again, fiber glass is not conductive out of the box, so there is no much signal interference. Now let's talk about carbon fiber, the most famous, the most favorite material of building drones these days. The cost is extremely high. carbon fiber is really expensive, and to find good carbon fiber, it's also not an easy task. And what is basically a carbon fiber is it's the fibers of graphite and some other carbon composite material, and they are made in a sheet, sandwiched together stacked together and paste using epoxy. On the durability side, they are very, very durable. Carbon fiber is one of the most durable material which you can use to build drones. And depending on how you post process or how you do some kind of things before making drone, it can be more durable. For example, what we as a drone builder, as a drone pilot do is we chamfer the edges using a very high grade file, and then we put some super glue on the edges, and that gives extreme durability even in crashes. So carbon fiber is extremely durable. Weight side is also good. It's not very heavy compared to G10 and wood. It's quite lightweight, so that is why it's also another favorable thing. So everything is good in carbon fiber. So what's wrong? So the wrong part is signal interference, because the graphite is a conductive material, and when you are talking about frequency, on the drone we have 2.4 gigahertz for RC link, we have 5.8 gigahertz for video link. So carbon fiber, so basically, consider it like this. So carbon fiber is conductive, but the epoxy and the coating of the layer on the top and the bottom, that is non-conductive. So out of the box, the frame you will get, that will not conduct electricity. But after some time, when you are crashing, when you are getting rid of that particular coating on the top and on the bottom, the conductive parts, the fiber of the carbons, they start appearing up, and that is conductive in nature. That can do some short circuit if there is some voltage leaking on the drone, and that is the major part which is responsible for signal interference. So signal interference happens in the carbon fiber if the frame is not maintained. So what could be the best of this both worlds? So in the engineering, everywhere we are seeing that the engineers, the manufacturers, they take some good part of this world, they take some good part of this world, and they come together. So I'll show you my drone frame. So I'll quickly go to this overhead camera, and you can see this is the drone frame which I'm using. So carbon fiber, very lightweight, very durable. There is signal interference, but that's okay unless you are maintaining a frame. There is no problem. But carbon fiber is also soft at some points, and they can break. They can get worn out over the period of time. And what these manufacturers are doing, they're using metal parts. So you can see here, this is a 7075 aerospace grade aluminum, and this is being used to enforce the carbon. So this is the best of the both world. I'm getting metal where it is necessary and carbon fiber on the rest of this place. So why we cannot make the frame of this metal, and why there is no metal on my slide? That is because metal is quite heavy, and that is not a suitable thing, and metal is conductive as well. So any leakage can cause short circuit. So but the best of the both world is carbon fiber with aerospace aluminum, which will give its durability where it is necessary. So there is a front end collision, the aluminum will protect it. Otherwise, the lightweight of carbon fiber is a goodness. So that is how the frame manufacturers are coming up with the best of the both world, and I think that is a way ahead. Alright, so let's talk about the quadcopter variants in drone frame, and I want you to come back to that same thought process, that whenever I'm saying drone, you think about quadcopter, the drone frame with 4 motors. So before that, let's talk about different things that change the flying characteristics, and the first thing is center of gravity. So the center of gravity is the balancing point of any body, and the drones are no different. They balance at a particular point where they have equal amount of balance in all direction in 3D space. So center of gravity, if it changes because of external part, like battery is one of the component of drone which carries most of the weight. So you can change the center of gravity of point by changing the position of gravity, changing the position of battery in the drone. So that changes the flying characteristics, how your drone is flying. So other thing is, if your drone frame has less material overall compared to another frame which has thicker arms, if your if your drone frame has thinner arms and so on, that would have less drag. And we discussed that in the last class, that the shape of the material and the amount of the material which is exposed to a fluid that contributes to the drag. So less material your drone frame have, less drag it would have. This is the most important part, that is the better balance is less work for flight controller. So in the last class we discussed that aerodynamically drones are unstable. They rely on sensors, they rely on onboard computers to maintain a balance, to maintain a stable flight. So if your center of gravity is off, if your drone frame is not perfectly balanced, so more work has to be done by flight controller to keep it balanced. So let's say if I move to the overhead camera to show you, let's say this is your drone frame, and your center of gravity needs to be at the center, so all the motors are doing equal part. But for some reason the frame manufacturer was incompetent and they designed the frame such that the balance is at the back. So ideally your drone would always be flying tilted this way. So what your flight controller have to do is always instruct this motor to spin relatively at higher RPM than these two motors, so that the drone can stay at balance. So what is happening here, your flight controller have to do more work, your one set of motor needs to do more work, and that is a lot of work and that is a lot of computation. So overall you will get a very less adequate performance from your drone. So that is also an intuitive unsaid thing that goes inside when choosing a drone frame. So better balance, better center of gravity, less material, that all accounts to a good quadcopter frame. So these are all the variants where you can find different quadcopter frames. So I have listed that on the left, and on the right you can see their photos. So we have X-type quadcopter, also known as True X. Then we have H-type. Then we have Hybrid X. I'm sorry, it's not Hybrid C, it's Hybrid X. Then we have Stretched X, and then we have Dead Cat. So this is the True X frame, which is in the shape of X or a cross. This is a H where it's in the shape of the H. So you can see there are 4 motors on all these, but the arrangement is quite different. It's X here, it's H here. This is a stretched X where you can see this angle is more compared to this angle, while on the True X, these the distance between these two motors and these two motors are same. Whereas in stretched X, the distance between these two motors is higher compared to these two motors. Then you take the H, you take the X, and you'll end up with Hybrid X. And square is also another kind of frame. Another special kind of quadcopter is a Dead Cat, as you can see here, where the angle in the front two arms is greater than compared to the back two arms. So let's talk about all these frames. So again, center of gravity on all these frames, the X type, the H type is different, and we have discussed that because of center of gravity there is a different in flying characteristics, and we'll talk about that in a bit. Less material is equal to less drag, and that is why you can see this small quadcopter here. It's called a toothpick drone because it has very thin arms, a very thin surface area exposed to the air, and this can go up to very high speed because of less drag. So this point holds valid in these kinds of frame. Better balance is equal to less work of flight control, as we already discussed. So in the X there is a very good balance because the distance between these two motors and these two motors are same. So there is very less computation this flight controller have to do. Whereas in something like H or the Hybrid X, it's quite different, and the center of gravity and balance is a bit off. Especially in the Dead Cat, as you can see, there is a shift in the center of gravity because of different angles of back and the front arms. So flight controller has to do more work. But the question is, why would anyone wants to choose these kinds of different quadcopters? All these are quadcopters, all these are 4 motors. We discussed that there are tricopter, hexacopter, but now why quadcopters in different configurations? So consider the True X, that is one of the most stable quadcopter, the most balanced quadcopter. So that is why if you're looking for stability, you can go with that. But the downside is, look at the space in the center. There is very less space you will get to mount your electronics. You cannot fit everything in the X frame. That is why the drone manufacturers, the frame manufacturers, they go for the H configuration. There you can see you get this bus like structure in the center where you can put your GPS, your flight controller, your video transmitter and antennas and so on. When you want the stability of a X and you want the space like H, then you go for the hybrid X, where the balance is like the X, the stability is like the X, but you also get more space to put all your electronics. But the downside is then this will have more area exposed and it will have more drag. So again, I mentioned that everything is a trade-off when you are building such things, so you need to find your sweet spot. The need for stretch X is so when we are racing, so stretch X are recently very common these days because of drone racing. So because of this weird distance between two set of motor, these stretched X kind of drones are very agile, very maneuverable in close turns and in any proximity flying kind of situation. So remember in the last video we talked about the how jet airplanes are using instability design as their advantage, for their advantage. Similarly, stretched X, because the balance is off, the air will not compensate for its stability. They will not provide for stability, so it can use this instability for its advantage and get high maneuverability, high agility, and it's very easy in the sharp turns for pilot, and the turns are very hard when you're drone racing. So stretched X frame especially are used by drone racers for agility purposes. Now similarly, if you see the dead cat configuration of quadcopter, see how the arms are in different angles. So 70-degree of angle between the front two arms and almost 50 degree in the back two arms. So why is that? Do you notice the small camera here? So that is the reason. Remember when I talked about the quadcopter, I mentioned that the quadcopter is not like tricopter, where you will get a very good angle in the front, so you can mount all your cameras and the propellers will not come into picture. Well, guess someone has a solution. So what they did, they make the front angle a bit more steeper, so you can mount this GoPro like cameras and still not get propellers into picture. But the downside is you will lose some stability. It's not a perfectly X. The center of gravity is way off, and the flight controller will have to do more work. It's very you will have a very hard time tuning it or making it stable. So that is the overall trade-off. So you need to decide. Talking about me, I fly this kind of configuration, hybrid X or H kind of quadcopters more. But these days people are shifting to true X and stretch X because of stability, and the components are getting smaller and smaller. The receivers were used to be very big couple of years back. They are comparatively smaller these days, so you can fit a lot of parts in this small area. So people are making a shift, but again, you need to decide for your own particular application. Okay, so here is another table which I created. So on the left you can see different drone configuration, and on the right on the columns you will see space, stability, agility, durability, and field of view. So talking about a true X frame, there is very less space, but the stability is very high, agility is also high. Durability again depends on how good the frame manufacturer has provided to keep the electronics safe. Field of view, you don't get a good field of view because the propellers are very close to each other. In the true H, everything is good except for agility because its center of gravity is again off, so more work has to be done by flight controllers and motors to keep it stable, and there you lose the agility. Hybrid X, the frame which I use, the FPV drone pilots and freestyle pilots and race pilot use, it's good in every department. Stretched X, again there is a space issue, but again it's good. Dead cat, you get a very good field of view, but you have to compromise with stability and agility. So a small word about drone frame assembly. So every drone has a different structure. Every drone has a different structural component and different physical components, and you need to consult the manufacturer. You need to consult some documentation which comes with it to assemble it. And if you are DIYing your own drone frame, then you know what to do. But let's shift to an overhead camera and I'll show you what I'm talking about. So this frame particularly comes with a single bottom plate and a top plate, and this particular part you need to assemble using the screw. This frame is comparatively very easy to assemble. It's just one bottom part and a top part. There are some another unassembled frames I have, which are mostly used for drone racing. So this is one frame designed by my friend. So this has a dual arms like structure. So you'll get two arms in one body. You have a bottom plate, and then you put some standoff, and then you have a top plate. So what I'm trying to say is that every frame is different, and when assembling a frame you need to consult the manufacturer documentation, and if any chance if you are building your own frame like a lot of people do, then you know what you are doing. So that concludes the drone frame selection part of this particular class. And as I already mentioned in the first class, I'm not going to recommend a one particular kind of frame or any part. So you know what best your application is, but I can surely show you what I use. So I use this Armatan Chameleon frame, which is a very good frame, and Armatan is a good frame manufacturer. This comes with a lifetime warranty. I'm not sponsored by Armatan or anything, but that is just what I use. So if you are interested into that. Okay, so now moving to the next part of this class, and this is very interesting and a lot of things we need to discuss. So let's quickly talk about transmitters and receivers, and let me show you how that looks. So here is my transmitter, and transmitter is your best friend in the hobby. And when I say best friend, I mean that this is the one thing where I will not recommend anyone to compromise. You can compromise on drone frame, you can compromise on other components, you can buy cheap one, but never buy a cheap transmitter. Never compromise on the transmitter. Please go for at least a good transmitter like this one. This is the FrSky Taranis X9D Plus. A bit expensive transmitter, but there are also some cheaper versions from the same company like FrSky QX7. There are also some more cheaper one by other cheap companies, but I will not recommend that, because this is something which is going to be your best friend. You are using this to control your drone. This is where the signal is coming from, and if you lose the signal, you will lose the drone. You will put people life into danger. So that is why I never compromise with transmitter. So let's talk about the communication link. So transmitter is the remote of your drone. Transmitter is the part which you are keeping in your hand to control the drone. Of course, if you are trying to make an autonomous drone, then you don't need a transmitter. But again, there are some cases, even in autonomous drone, where you need transmitter to feed one-time information or so. So transmitter is the remote which you keep in hand, which you use to control your drone. Receiver, on the other hand, is the component which stays on your drone, which receives the command, the input from the transmitter about the roll, pitch, yaw axis, the throttle, and how you want your drone to react. So this stays in the drone, and they communicate together over a radio frequency link. So they work on radio frequency, RF channel. If you are not familiar with the RF frequency, it's basically electromagnetic carrier waves which carry information. What kind of information? So it carries, in this case, it carries information of roll, pitch, yaw, and throttle. How much yaw you want, how much degree per second of roll you want, how much throttle you want your drone, and what's the overall attitude you want your drone to behave. So talking about the communication link, the transmitters and receivers generally work on ISM band, that is a 2.4 gigahertz. So there is a frequency band available which are free to use around the world. It's called ISM band. Your routers work on that, Wi-Fi or Bluetooth works on that, and a lot of different things which do not require any license work on that. So again, 2.4 gigahertz is a ISM band, and if you are using the ISM band in a restrict power levels, then you are free to use without any license. For example, in India, where I come from, if you are using other frequencies which are not a part of ISM band, then you need a ham license. Then you need a special permission from communication ministry of the government to do any communication on that frequency. But 2.4 gigahertz under a certain power range is free to use. And yes, these transmitters have a power on which this transmits the signal. If I talk about the radio transmitter which are used in drones and RC hobby, the general transmitting power is around 10 to 15 milliwatt, and that gives you a range of around 1 kilometers in a good line of sight open space, which is good enough. And we'll also talk about how to increase that and stuff like that in later slides. Okay, so One question which could arise is I want to fly with my friends. We have 10 friends, we all have drones, we want to fly together. Will there be any interference? And that is a really good question. And to answer that, it's not, there will be no interference. But how is that possible when everyone is flying on the same frequency? So the answers lies in a thing called frequency hopping. And what frequency hopping means, that the transmitter and receiver, they decides that we will be keep on changing frequencies every certain time, and we will know we are hopping from one frequency to another at the same time, so we can communicate. And this frequency hopping allows a lot of pilots to fly together. They allow a lot of people to use same frequency without interfering one another. And there is a very steep, very less chances that you will end up interfering with some other. But that is not really the case. That I have seen in big RC events, around 200 people flying together without any problem. And that is how frequency hopping work. So frequency hopping is built into the transmitter and receiver, and when you bind the receiver with the transmitter, they agree on the algorithm used for frequency hopping, and that allows a lot of pilots to fly together. So 2.4 gigahertz, I told you, is the ISM band which this radio uses, but you can also use 900 megahertz and 433 megahertz depending on where you are in the world, or if you are allowed to do that. You can also extend the capabilities of this transmitter, which we'll also talk about in later slides. Frequency limits as per local transmission laws, so that holds true for everywhere in this world. So government controls what frequencies you can use, what frequencies you cannot use, what power levels you use. So please consult your local radio transmission laws before doing anything which may land you in problem, like illegal transmission on illegal frequencies. Might need a ham license to transmit certain frequencies. That holds again true. If you want to do some frequency related stuff, you want to transmit in some certain frequencies, you might need to apply for a ham license, and generally you need to give a test. You need to give a test on electronics and antennas and radio frequency to get this ham license. So if you are serious in this hobby and you want to continue pursuing it, it's also a good idea to take that license as well. Power of transmission is also limited by local laws. As I mentioned, that these transmitters, they work on 10 to 25 milliwatt, which is good enough. It will give you a range of around 1 kilometer or 1 mile, depending on what is the power level, and that is a good enough range. Range depends on a lot of different factors, which we will also be talking about in great details. But one such factor is like how dense in an area you are flying. So if you are flying in an area with a lot of buildings, lot of concrete walls, then you will obviously have less range compared to if you are flying in open space where you have good line of sight for your drone and such kind of things, and also where your antenna is facing at a particular time and what is the direction of a receiver antenna. That also matters a lot, so we'll talk about that in coming slides. Now let's talk about frequency, RF power, data rate and range. So when I was teaching about drones in my local area to my students, there is a common misconception, and that misconception is that more the frequency, more is the range. So they think that 2.4 gigahertz frequency will give them more range compared to 900 megahertz, and that is a misconception, and that is not true. In fact, at same power level and at same modulation, lower frequencies will give you more range. Example, 900 megahertz will give you more range as compared to 2.4 gigahertz. But that is one when you are comparing apples to apples and not apple to orange. Make sure that when you are comparing any frequencies, they are transmitting on same power levels. Obviously, if 2.4 gigahertz radio is transmitting at higher power level, you will get more range. But if they are on same power level, they are using same modulation technique, then lower frequencies will give you more range. Also, lower frequencies wavelength are bigger, and therefore they have better penetration. So it's a simple formula: C is equal to mu lambda. C is the speed of light, constant. That is 3 into 10 raised to power 8 meter per second. Mu is the frequency and lambda is the wavelength. So by this formula, frequency is inversely proportional to wavelength. So more the frequency, less is the wavelength. Less the frequency, more is the wavelength. So obviously 900 megahertz signal will have more wavelength, bigger wavelength, and it will give better penetration capability. So it can penetrate better through walls and concrete structures and whatnot compared to higher wavelengths. Also, more data rate is equal to less range. So what I mean by that, if you are transmitting 2 megabits per second, you will get less range compared to if you are transmitting, let's say, 2 kilobytes per second. So you need to make sure that you are only transmitting the minimum amount of data and not excessively using the channel, because there are certain concepts which are involved and which reduces the range. These are out of scope for this particular class, but I'll just throw some of the jargons at you, so you may Google out if you want, out of your interest. So there is a channel limit, there is channel bandwidth, and then there is link budget, which hampers this data rate and ranges. So feel free to Google this out, and let's bring question to officers if you want. But for this particular session, you just need to know that more data rate means less range. Okay, so moving ahead, one might ask that if lower frequencies are providing more range, they have better penetration capabilities, then why are we using high frequencies? Then the answer is simple. So higher frequencies, that is a 2.4 gigahertz or 5 gigahertz or 5.8 gigahertz, they comes under the ISM band, and they are widely accepted as free to use band around the world. So if you want to buy one transmitter and take it anywhere into the world, you don't want 900 megahertz. Maybe you are allowed 900 megahertz in Asia, but if you are moving to US, you cannot use it because it's used by some other cellular communication, and lower frequencies are generally used by cellular communication. That is the last point. In India, I think there is 800 megahertz which is reserved for cellular communication, that is your mobile communication. So obviously you cannot use that. That is a link which is assigned to that particular task, and you don't want to jump into that and jam that signals or populate that particular band. Other reason which you might want to use high frequency is more bandwidth. So higher frequencies gives you a more bandwidth. There are more channels in the bandwidth in the same frequency range. So I'll give you a simple example. If you have ever seen the Wi-Fi router, there are Wi-Fi channels. It says you want to transmit on channel 11, channel 7. So if you don't, you just need to log into your router and see on what channel it is transmitting. It is transmitting in 2.4 gigahertz, but that is not exactly 2.4 gigahertz. It can be 2.40 gigahertz, it can be 2.44 gigahertz, or it can also be 2.6 gigahertz. So this is the entire bandwidth, the entire range on which the frequency is divided. So the higher frequencies gives you more bandwidth, so you have more number of channels. It also helps in frequency hopping. So more number of channels you have, better you can hop these channels. So that is another reason to use high frequencies. Another thing is small antenna size. So lower the frequencies is, the bigger antenna size it gets, and we'll understand that in a bit in later slides. But for now, just understand that lower frequencies need bigger antenna for transmission, higher frequencies need smaller antenna for transmission, and you do not want to go on a field and take a massive 3 feet antenna with you for flying a small FPV drone. So that is why you need to have high frequencies. And again, the last point I already mentioned, that lower frequencies are generally used for cellular communication, and you are not allowed to transmit in that. Another thing which someone may ask is, so this radio on the left is transmitting at 10 milliwatt. So we need more range. How about we increase the power? We make it, let's say, 1 watt. So we will get more range. So that is true, but you can do that. So, but it's not as simple as it seems. There are legal aspects involved. There are authorities which are responsible to see that you are under limit and you are not transmitting at very high power. Increasing the power increases the range, but there is something called inverse square law. So it doesn't mean that every signal which you are transmitting is receiving to your receiver. Some signal goes to the open space and they get lost. So if you are doubling the power, you do not double the range. That never happens. It's called inverse square law, and we will discuss more about that in the FPV chapter, which is due to come. There is something called antenna gains. Antenna also has gain. It is not an active component. Antenna don't have batteries, but they have gains. Something we will also discuss in the FPV chapter, not now. But for a rule of thumb, just know that twice the increase in power is equal to 3 dBi of gain of isotropic antenna. So So to get to get 3 dBi increase of gain, you need to increase the power by 2. So that is a small maths there. Again, you do not need to stress on that. We will talk about that later in the FPV chapter. But for now, these are the answer of why we cannot we are using high frequencies, and why we cannot just simply increase the power to get more range. Last thing I want to talk about in this particular side is antenna dead zone, and that is one topic that I want to take on the iPad. That is my whiteboard. So let me switch to that and let me show you what I mean by antenna dead zone. Okay, so I am on my whiteboard, and I hope I am able to draw. Yes, you can see. So in a schematic, an antenna is generally represented like this. So this is an antenna, and if you look on my overhead camera, and if you look on this transmitter, so this is the antenna. This is also known as a linear antenna or rubber duck antenna. So this kind of antenna, it transmits in two directions, and this transmit in this direction. This is called a lobe, and this transmit in this direction. This is called another lobe. So this is my antenna, and this is transmitting in this direction, and this is transmitting in this direction, and there is no transmission in this direction, and there's no transmission in this direction. So these two directions are also known as the dead zone. So you always want to face your antenna this way if you are flying your drone over here, or if you're flying your drone over here. But as soon as your antenna of your drone comes in this particular direction or this particular direction, it will receive no signal, and it will do something called failsafe, which we will also be discussing in another slide. But just for now, understand that every antenna has dead zone, and every antenna is having a particular shape. The antenna which we are using on our transmitter, it's called linear antenna, and the property of linear antenna is it only transmits in these particular lobes. So there is no transmission in this direction, and it's like a cone. So the far you go, the far the cone gets bigger, the far the transmission is. But as soon as the receiver comes in these particular directions, then it may lose the signal. So make sure to always keep your antenna facing this way and your drone in this way. So this particular property can be changed by changing the type of antenna, and there are more antennas like circular polarized antennas or direction antennas. So moving on, let's talk about the number of channels. So every transmitter has some channels, every receiver has some channels. So this transmitter which I have has 16 channels, and let me move to the overhead camera to show you what are different channels. So this one has one channel for throttle, one channel for roll, one channel for pitch, one channel for yaw. So these are 4 channels. Apart from that, every switch is one channel. So these switch are also like channels. These joysticks are also like channels. These pods on the sides, on the back. So all these are channels, which means every particular channel is sending one value of data. So this is sending one value of data, that is pitch. This is sending one value of data, that is roll. And you can program this to send different values. For example, I have programmed this one to change the mode of my drone, and we will discuss mode of the drones in software class, where we'll talk about what are different modes you can fly on drone. So for going to mode 1 to mode 2 to mode 3, I have used this channel. So this is also sending data to my receiver, and that data will be passed to the flight controller to do some calculation, and on the basis of that calculation, the mode of the antenna will change. Also, these joysticks can send some data. For example, this can send if I want to ascend my drone, or I want to descend my drone in particular intervals and whatnot. So generally speaking, for a drone or for any RC hobby, for planes or something, you need at least 6 channels. So roll, pitch, yaw, throttle are 4 channels, and 2 channels more are good to have. So information is transmitted over the channels. So every channel contains particular type of information. For example, throttle, yaw, pitch and roll. These are information which is transmitted. There are auxiliary channels which we talked about. So these are auxiliary channels which you can use to program what value you want to send. these channels are multiplex, and what I mean by that is so you have one frequency and all the information from this channel is going to that one particular frequency, one particular radio frequency channel. So you need to do some kind of multiplexing. So generally it's time division multiplexing, that is all the channels are separated by a small time interval, so it is easier for receiver to interpret what is the value of throttle, what is the value of yaw, and so on. So receiver and transmitter can have different number of channels. For example, this transmitter has 16 channels, but this receiver only has 6 channels. So you can send maximum 6 channels only to this receiver. If you try to send more than 6 channels, it will discard the channels which are coming after the 6 channels. So that's how it works. Number of channels at RX site matters. So obviously, because this is the receiver which is going to be mounted on the drone, so this receiver is sending data to your flight controller, so the channels on your receiver, that is the only thing that matters. You can have 16 channels here, but you can only use 6 channels because your receiver has the limitation. Now let's talk about transmitter and receiver protocols, and to understand that, see this one diagram. So this is your radio transmitter, this is your receiver, and this is your flight controller. So your receiver talks to your flight controller and your transmitter talks to your receiver. So on the transmitter side, you have a transmitter protocol. That means the protocol on which the receiver and transmitter talks. And on the flight controller side, you have the receiver protocol. That means how your receiver talks to your flight controller. So talking about the TX protocol, that defines channel multiplexing, that defines modulation, that defines frequency hopping and error check. So basically, in a nutshell, what happens is your transmitter and your receiver both uses a radio frequency chip, a 2.4 gigahertz chipset, and on the top of that chipset, they make their own protocol, that how we are sending each channel. We are sending throttle first, or we are sending yaw first, and how frequently we are sending, what is the modulation we are using, what is the frequency hopping algorithm we are using, and what is the error check we are doing. So this is mostly a digital signal coming from transmitter to receiver, and this is a proprietary. So these are not open source, these are not protocols defined by the community. The transmitter and the receiver manufacturer, they decide that protocol. So generally speaking, you can find the protocols such as D8 and D16 for FR-Sky transmitters, and you can find protocols like FAST if you're using a Futaba transmitter. So these are transmitter companies which make transmitters. If you're using a Spectrum transmitter, then the protocol they are using is called DSM2 or DSMX. So your receiver and your transmitter both should understand same protocol. So that is why the compatibility comes into the picture. You cannot use any receiver with any transmitter. They both need to understand each other language. They both need to understand each other protocols. That is why TX protocols are important. And again, these are proprietary protocols. The manufacturer designed them as they want. However, on the RX side, the receiver communicates to the flight controller, and this communication link we will see in more details in the flight controller chapter. But for now, you can understand that these protocol can be generic. They cannot be they cannot be proprietary. So generally speaking, like it can be generic, like pulse with modulation, pulse position modulation, pulse coded modulation. So these are kind of modulation techniques used in signal and digital signal transmissions and whatnot. We will talk about that in flight controller chapter, so don't worry if the term scares you for now. It can also be proprietary, like S-Bus was developed by Futaba, and CRSF is developed by Team Black Sheep. So these are drone manufacturers. It can also talk on an analog signal, like PWM and PPM are analog in nature. They are not digital signal. They are not zeros and one. They are actually analog waves which are sent out and interpreted by the flight controller. But it can also be digital, like S-Bus and I-Bus. These are the protocols which are based on zeros and ones. So digital is of course a better, more reliable signal. Also, receiver can send data to flight controller in a parallel fashion. Like for example, if this receiver has 4 channels: throttle, pitch, yaw, and roll. So each channel can have one wire of itself. Throttle can have one wire going to the flight controller from receiver. Yaw can have another wire. So each wire carries one channel. that is called parallel communication. So example of parallel communication is PWM protocol. But this receiver can also send all the data in single wire, like I have seen here. So red and black are the power for receiver, and yellow is a single wire on which all the data of throttle, yaw, pitch, roll, and auxiliary channels are transmitted. So example of serial protocols are S bus, where only one wire is used for for all the channels. While on the parallel, each channel will get one wire of its own. Few takeaways. So one transmitter can offer multiple protocols. For example, there could be one transmitter in the market which can do D8, D16, and also do DSM2. TX and RX protocol are not interdependent. That means TX protocol can be different, RX protocol can be different. You may have RX that speaks D8 and that speaks PWM and also S bus. But they are not mutually dependent, and they don't defines if you are restricted by particularly one kind of protocols. That is not the case. End of the day, it's all about latency. So all these protocols. So the question is, why do we need all kind of protocols? Why do we need D8, D16 here? Why do we need PWM and S bus here? So it's all about latency. So as the demand for fast and fast drones, fast and fast signal processing comes into picture, as more research are happening in these areas, the latency is going down, and these new protocols, they provide more real-time communication and less latency. Okay, so in the last slide, I told you that the transmitter which we are having out of the box, they can transmit at 2.4 gigahertz and 10 milliwatt, but that doesn't mean you need to restrict on that frequencies, on that power level. Some good transmitters like the one I'm having here, they have something called a JR Bay, which is exactly like an extension port. Where you can put external modules and increases its capability. So for example, you can add something called LRS, which is known as long range system, or UHF called ultra high frequencies. So this is the kind of module I'm talking about. You can see on the photo, this one is Easy UHF by a company called Immersion RC. It's an ultra high frequency module, and this is a Team Blackship Crossfire, an LRS module, or long range system module as it called. So on the back of the transmitter, I'll show you on my transmitter. So on the back, you have a port which you can open up, and you can see there are some pins on which the external modules can be connected, and this increases the range and it increases the capability. So what you are doing here is basically you are increasing the capability of a transmitter. You are changing the frequency because this module runs on different frequency. If I remember correctly, it works on 900 megahertz, and it can change power level up to 1 watt. So you can increase the power level if you already have permissions to do that, and if you have programmed the module correctly. There are some programming might be required, some configuration might be required, but basically you can change the frequency, you can change the protocol. So by default, this transmitter works on D8 protocol, as I told you in the next slide. But this module has its protocol on its own. It's called CSRF. So you can do that. So not every transmitter has that. So only the good, a bit expensive transmitter provide you these capabilities. But again, it's very flexible. And one of the good thing which you can do is you can also make some DIY modules. Like on the left, you can see a picture of NRF24 module, which is a very common module RF used with Arduino, and you can control your own homemade drones, homemade transmitters, or a small drone if you have made using these kinds of radio. So overall, these transmitters run some open source firmware. So if I talk about my transmitter, it runs an open source firmware called OpenTX, and you can change the code. You can program your own external modules. You can take the advantage of this JR Bay, where you can plug external modules. So basically what you are doing is you are disabling the internal radio chip, and you are enabling the external radio chip which you have plugged. And based on that, you can attach these modules to different receiver, different antennas, and you can get different frequencies and protocol. So that is the entire idea of making it modular and extending its capabilities. So this is a transmitter, and it talks to a receiver. But this receiver can also talk back to transmitter, and this concept is known as telemetry, a very powerful concept. And let's understand why you want your receiver to talk back to your transmitter. So receiver is mounted on your drone. transmitter is in your hand. So why do you want your receiver to talk to your transmitter? So it's very simple. You want to have the knowledge of your drone current GPS coordinates. You want to know the current battery status. You want to know the current speed. So this can be done with the receiver. But the question is, this is a small receiver. This does not have a GPS inbuilt. This does not have a voltage sensor or a speed sensor. Then how this receiver is passing this data to the transmitter back? The answer is very simple. This receiver is talking to the flight controller. The flight controller knows all these. The flight controller can send this data to receiver, and receiver can send back to the transmitter. So basically, this is not a receiver. This is a transceiver. It can also transmit. So that is a powerful concept, and this is known as telemetry. We will see in the greater details. And if I go to the overhead camera,
welcome to OpenTX.
You might heard that my transmitter speaks to me. So when I'm flying with the goggles on and I want to know my battery status, I can flick a switch like this. So for that, I need to program it. So I can flick a switch like this and it will speak the current battery to me. I can flick a switch like this and it can tell me the current flight time. So this is the powerful concept called telemetry that is sending data back to the ground station, and receivers like this can do that. So you'll see two antennas. That is not for redundancy. One antenna is to receive and another antenna is to transfer back to the ground station. Okay, so let's move ahead and talk about the antenna. So basically, on the receiver side, the length of antenna or the shape of antenna, that doesn't really matter. It does matter, but not at that extent as it mattered to a transmitter, because a transmitter is sending signal out at a power, and if the receiver is not good, the antenna is not good, the antenna is sketchy, or the antenna is not designed properly, there is no impedance matching. There is a concept called impedance matching that is used everywhere in electronics. So if antenna is not particularly matched for that frequency, and because the transmitter is sending signal out in some power, it can burn the transmitter, because there is no way the signal is going out. The transmitter wants the signal to go out via an antenna, but the antenna is crappy, it will burn the transmitter. So the design of antenna is very crucial there. So you might be thinking that, Ayan, you told us that on higher frequencies the antenna length is very small. That is why we use higher frequencies. We are using 2.4 gigahertz, which is very high frequencies. Then why we are having such a big antenna? And if I take you to an overhead camera, you can see the length of antenna is quite big. So this is my receiver, and this is the antenna. It's quite big, as you can see here. So this is my receiver, and this is the overall length of the antenna, which is quite significant big. So you might be thinking that why is that, even though we're using high frequencies? I'll say that this is not a big antenna. You just need this small length, the exposed length. It is also known as the active element of this antenna. So this is very small, you can see. So only this exposed length matter, and this length which is covered does not matter. This is just there to provide you with some extra length. So in case you crash your drone, the antenna breaks, you can peel off this length back and you get back the active element. So this is nothing but a coaxial wire, which is having a wire inside it, a coaxial wire inside it, and only this exposed length matters. So you can see how small is that. Only that length is matter for the transmission, and this is just to have some extra length in case you break this. You can peel off back and you can get the good range back. So range is very sensitive to length of the antenna, and if you cut a small piece here, let's say even 1 millimeter, you will get very bad range. You will start having signal losses. So make sure to have a proper range. So again, the same point when I say that my transmitter and receiver works on 2.4 gigahertz, I mean the 2.4 gigahertz band, and this is the entire frequency band, which may range from 2.4 to 2.8 gigahertz and so on. So how do we calculate this length of this exposed antenna? How do I know what should be the length of my exposed antenna? So it's a simple formula. So the wavelength can be calculated by dividing frequency in gigahertz by 300. So the band is 2.4 gigahertz, which range from 2.40 to 2.8. So let's take 2.44 gigahertz as the middle band. So if we divide 300 by 2.44, we will get 122.95 millimeter of wavelength. and the length of antenna is wavelength divided by 4. So 122.95 divided by 4 is equal to 31 millimeter. So 31 millimeter or 3.1 centimeter is the only antenna of active element you need on your receiver. So that's how small it is. A receiver connection with the flight controller, we will discuss that in flight controller, but I've already mentioned that there are two kind of connection you can do between the receiver and the flight controller. One is the parallel, where each channel have its own connection. Throttle has its own connection, roll has its own on wire, pitch has its own wire, and so on. In the serial, there is only one wire and all the data of all channels is transmitted to that particular wire. There is one thing that I need to mention, that is called Failsafe, that I already showed you on the whiteboard, that this antenna transmits in two lobes on the left and the side because it's designed that way. So on the center there is a dead zone, and that is where the failsafe happens. So what is a failsafe? So this transmitter and receiver had a particular range. Let's say it has 1 kilometer range, and if you exceed that range, if you take your drone beyond 1 kilometer, you will lose the signal, or you will lose the signal if you come into the dead zone. So one thing in the drone which will trigger when you lose the signal to your transmitter, it's called failsafe. So what is a failsafe? Failsafe is a situation which happens when the transmitter and receiver can no longer communicate. Maybe they are out of range, maybe there is some interference, whatever, they are not able to communicate, and a situation of failsafe happen. As a drone builder, as a drone pilot, you have the liberty to choose what you want to do when this situation happen. So one thing which you want to do is cut off the motor and let the drone fall as a rock. One thing you can do is let the drone fly as the same altitude it's flying. One thing you can do is let the drone ascend very slowly. So depending on that, you can program in your flight controller what you want to do when the situation of failsafe happen. The last thing I want to show, we need to go to the overhead camera. So I have done a small setup here. So this is my transmitter, and I have one receiver here which is connected to two motors, one servo motor and one brushless DC motor. So how do my transmitter know? So how do my transmitter know that it needs to talk to this receiver? So we need to do something called binding of receiver. So I need to bind my receiver to my transmitter, and every receiver has different process to bind it. In this particular one, I don't remember, but there is one button, or you need to short some pins and connect to the battery. For example, in this receiver, there is one button here. You need to put your transmitter in binding mode. You need to press the button and you need to power it on, and it will bind together. So you need to consult the documentation of your particular transmitter and your receiver, and you can able to bind that. But over here I am already bounded these two. So this receiver is bounded to my transmitter, and I want to show how it rotates this motor. So I need to give power to this. Okay, so I have bounded this receiver to my transmitter already. This is the receiver, and this is bounded to my transmitter already. You can see the green light. And I have connected this servo motor to the roll axis. So if I do roll, you can see the servo is moving on the roll axis. There will be no another movement on any other axis because it is on the roll axis. So I have connected my roll axis to the servo, and I have connected throttle to this motor. You can see as I give throttle, the motor.
Telemetry lost. Telemetry recovered.
Now I want to show you the failsafe situation, where what I will do, I will power up the motor and I will switch off the transmitter and see what will happen. So I'll power up the motor.
Telemetry lost.
And I switch off my transmitter. And you see, as soon as the transmission signal is lost, the motor stopped. That was all for today's class. I hope you get to know a lot of different things about frequency and transmitters and frame selection, and there are some myths you would be having before that is now solved. So thank you very much for joining, and I look forward to seeing you all in the office hours. So thank you very much, and see you in the next class.